Okay, so we are come to chapter 5 now, and we talk about system of linear inequalities and linear programmings. In this section, in each chapter, we're gonna have section 5.1. We're talking about inequality first. Let's have a quick look of that. So when solving an equation, for example, like 3x plus 2 equals to 5, the solution is just one number. And in this case, the solution is equal to 1. However, when we switch the equality sign to the inequalities, so we change to be 3x plus 2 less than or equal to 5. Say less than or equal to 2, which is in the notation as less than or equal to, like that. The one under here, right? Less than or equal to. Okay, and then the solutions solution will be like a set of number. So let me let's first investigate what we are allowed to do exercise of an inequalities. Okay, so first I say adding a number to both sides. For example, 2 less than 5. Okay, so maybe I have to have something like less than will be this way, greater than will be that's one, greater than or equal to, it's going to be this notation. And so we know that everyone knows that 2 is less than 5, right? If you adding both sides, by a number, you will not change the direction of the inequality. So let's say 2 plus 4 less than 5 plus 4, right? Adding with anything, it will end up same as 6 less than 9. And you see that, right? You add both sides by 4. I have 2 and 4 is 6, 5 and 4 is 9, and I can still end up with 6 less than 9, and the direction of the inequality is not changing. What about subtracting a number on both sides? Say 2, keep 2 less than 5 again. We have let's say subtract both sides by a number. Let's do 2 less than 2 minus 3 and less than 5 minus 3, right? Is that the true statement? Let's check. Have 2 minus 3 is -1. Less than 5 minus 3 is 2, right? So this still work. So this work, right? So subtracting a number on both sides still work and will not change the direction of the inequalities. Now what about multiplying a positive number on both sides? Keep in mind with the word positive number, right? what happened, right? So keep doing with 2. 2 times with 3, right? 3 was greater than 0, right? It was positive number. 5 times with 3. Is that change? That will become, oh, actually, I'm going to start with 2 less than 5. And I will have 6 less than 15. Is that true? Yes, it is true. And what about dividing a positive number on both sides? Let's do 2 less than 5 again. And I divide both sides by a positive number. Let's do 2 divided by, I don't know, maybe 3. And less than 5 over 3. Is that true? You can check with calculators. If you have like 2 divided by 3 is going to be 0.67 something. And 5 divided by 3 is about like 1.67 something. But as you know, that's, 2p's in 2p divided by 3 is, must be less than 5 over 3. Okay, so so that also true. Okay, so I will say true. And lastly, okay, so I want to have use the red color here. Negative number. Okay, so with negative numbers, what happened, right? I will have, say, 2 less than 5 again. Okay, then I have, say, 2 multiplied by -1. Let's do the easy one, right? 5 question mark with 5 multiplied by -1. So what happened now? I have -2 to the left, and I have -5 to the right. Oh, -2, is that less than -5? No, it is greater than -5. Okay, so what happened? This change the direction. Okay, change the direction of inequality. Yeah. What about the other side? And you back. What about the other side? You're going to do 2 less than 5, right? And I do 2 divided by a -1 is that what happened? 5 divided by -1. What happened now? You will see -2 again, and it is greater than 5, right? And so that means this also change the direction of inequalities. So because of this, right? Because of this, we can make a note that don't multiply or divide inequalities with um, with a variables, because we don't know if it is negative or not. Okay. So if you have inequalities, don't multiply or divide both sides of inequalities with a variables. So inequalities put that here. So don't multiply or divide both sides. Yeah, let's say this. Okay, so that is it. Okay, so I also include the number line here for you guys to check which one is greater than which one. So, and you see over here, if I have say -5 and -2, right? You will see that -5 was less than -2, or in another word, we say -2 greater than 95, right? Same thing over here, right? Yeah. Okay, so now let's do an examples. I want to solve the columns 12 minus 4x less than 6. So we have 12 minus 4x less than 6. What we do is we have to subtract both sides by 12, maybe. So -4x less than 6 minus 12, right? So then it signifies have -4x will be less than -6. Right. Okay, now you multiply both sides or divide both sides by -4. Okay, divide both sides by -4, which means you have to change the direction, and you have -6 divided by -4. I will write in here, say divide both sides by -4, right? And then because and then so then it signifies you get x equal to 3/2. Okay. Oh, sorry, x greater than. Thank you. All right. So what does that mean? Okay, 3/2, if you convert it to decimal number, it's gonna be x greater than 1.5, right? So let me make this become blue. So what happened? What does that mean? If we want to present it in the number line here. So I will have to have a I had to have 1.5 first. Where that should be around here, right? So 1.5. Put this 1.5 here. Okay. And make okay. Then this say that x greater than 1.5. So that means I have to have a line go all the way to the positive infinity from 1.5. But do we include 1.5? It's a greater than 1.5, which means you not include 1.5, right? So you must have an open circle there. Okay, open circle mean open circle mean do not include. Okay, do not include it. So so in this case, as you can see that I not include 1.5. Okay, and I just go 1.5. Okay, so now we're gonna move to example 5.2. Now read it. Okay, a company spend 1,200 per day on overhead and labor, and each item they produce cost $5 for materials. Okay, so last we have 1,200 per day on overhead and labor, right? So there is another one named so each item, right? Each item costs $5 for materials. And if they sell the item for $15 each, so this is the price, fixed price, right? We'll say fixed price at 15, right? How many items will they need to sell each day for the company to make a profit? Okay, so since they ask us the question say how many item, right? How many item will they need to sell them to make profit? Right? So I'm gonna label as X is number of items produced, right? And need to sell. Need to sell. Yeah. Yeah. So we will have C of X. We will have to make the cost function as fixed costs over here 1,200, right? And per item cost, right? Per item cost V equal to $5. So I'm gonna have 1,200 plus with maybe I write as F plus Vx. So then we have C of X equal to 1,200 plus 5x. Okay. Then I also make the revenue function because this one revenue going to be equal to price times demand, right? Because this one have price is $5. So it's going to be x equal to 15 times x. So we need to find the profit, right? Profit function will be revenues minus cost, which equal to 15x, and then a minus for the whole cost function. I need to put in the parentheses 1200 plus 5x, and then equal to 15x minus 1200 minus 5x. And then I have P of x simplify gonna be 10x minus 1200. So this is the profit, right? We in the question say we want to make profit, which mean profit must be greater than 0, right? So then I'm gonna set up 10x minus 1200 equal greater than 0, and I solve for that. So I'm gonna add both sides by 1200. I have 10x greater than 1200, and then I divide both sides by 10. I get 1200 divided by 10. Then I have x greater than 120. So that means what? I'm gonna write here. Company need to sell more than 120 items a day to make a profit. Sorry. All right. So we're gonna have exercise 5.1 below. I would like to let you try it and solve for it. Answer key will be x greater than 2, and this one gonna be x greater than or equal to -2, right? So keep in mind that this includes the -2. So you must have the, instead of open circle, you have closed circle, right? For -2, and for the left part, you must have open circle at 2 here. Okay, so try that, and we'll see you in the next session, right? This one. All right. Okay. See you in the next session.